So what if I have more than one level with my IVs? Well, I can go from a two-way ANOVA, or this 2x2, to maybe even a 3x3. So if I'm going to do a 3x3 factorial ANOVA, right? So maybe instead of therapy and no therapy, my options here are therapy once per week, once per month, and then none, right? And then drugs are, I don't know, what, no drugs, 1 per day, 2 per day, right? Again, not a clinical psychologist or a psychiatrist, so I don't really understand all this stuff, but I get the idea that you can take 2 pills in a day, right? So ultimately, this is a 3x3 factorial design where I have 3 levels of one factor and 3 levels of the other factor, my IVs, right? And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 3 squared, 3 times 3 possible combinations of these things. Now, as I'm doing this, my assumptions don't relax, right? I still have to have have people in each cell. The number of people in each cell should be more or less the same, and the variances across the cells should be more or less the same. In other words, all of my participants should come from the same population. And then I can, again, compare means across all of these cells, and ultimately that's what the ANOVA is telling me. Is one or more of these means systematically different from the other, right? The means of the DV, right? So social anxiety, I have the mean here, the mean here, the mean here, the mean of this group, the mean of this group. I have all 9 means, the means of all 9 groups of participants. All these groups are set up based on different levels of my 2 IVs. 9 different groups. I take the mean of each level, the mean of each group then that represents all of these different combinations, and I compare these means in one large omnibus test that I do via factorial ANOVA. And that tells me if one of these 9 groups has a significantly different mean than the other 8, right? Or if 2 of them, or 3 of them, or 6 of them, or however many, if one of these is different, then I will get a statistically significant result. I'll have an F test, just like in one-way ANOVA. I'll have a statistically significant F, and that tells me that somewhere in here I have a mean that is systematically different from all of the one or more of the other means in my matrix of possible outcomes.